Cool. All right, cool. Now, I guess I'll just hand it over to you, Itay. And once again, thank you so much for joining us. I know it's Friday and it is over in Israel, which, it's the most inconvenient time I could possibly have cloud security office hours. But thank you for joining us.
Thank you for having me, and don't worry, I got harder times, like 10 p.m. Saturday night. So this is chips. So like nice to meet you all. And I think I'll start with the presentation. But before I do, just want to say, feel free to jump in and ask anything. Sean talked to me about it before, and I really love the open debate. I'll try to keep an eye on the comment section in the Zoom, but if I miss you, just pick up. Cool. So let us begin. Once I'll find my, yeah, just do that.
Just another note too, if you do have a question, there's a little raise your hand icon at the bottom of the screen. Just raise your hand up and we'll get to you as soon as it's convenient.
Cool. So I decided to talk about two topics in cloud detection engineering, which I really love. And I think these are extremely interesting problems that really opens up how to operate in a SOC team, like what the infrastructure that a SOC team needs in order to do their job. And they could be perceived as very niche, but they just open up so many opportunities that I really love these issues. And cool. So before we dive into it, I just want to do a quick intro for myself and what made me into such a detection engineering geek. So as Sean said, I started in GEM, and my first position in GEM was a core engineer. I was one of the three first engineers in GEM. And during my first year in GEM, we've built the ingestion, detection, and investigation platforms of GEM. What GEM built is a CDR, Cloud Detection and Response, a platform for SOC teams. After a year of building it, I moved to the research team and I led it. And we were responsible for the cybersecurity content of the detection engine, like all of the hopefully amazing and cool and high fidelity detections that GEM had. After that, we were acquired by Wiz, and we built our engine inside the Wiz platform. And this was like an opportunity to see huge scale up. In GEM, we had a couple of dozens of customers, and in Wiz, it's like a whole bunch of them. So with it came more challenges that we needed to answer in order to keep on creating high fidelity detections. And yeah, go ahead, Matt.
Okay. Oh, I think that was just a hot mic there. Go ahead, Itay.
Cool. So I think throughout the last couple of years where I built and created content for detection engineers and SOC teams, what I really learned is that in order to have high fidelity detection, in order to have fast triage, you must have great detection engineering. Because without the infrastructure, the needed infrastructure, you can't really do these cool, amazing correlations and cool smart logics to catch attackers. And you can't really do very smart and fast investigation. So I think the infrastructure of detection, doing fine detection engineering, it's a lot of times it's overlooked, and I really want to put a spotlight on it. So that's my intro. And today we're going to talk about two topics: role unchaining in AWS and event parsing. These specific two topics are very AWS focused. GCP and Azure and the identity providers and other SaaS that are sort of near the cloud, for example, Snowflake or GitHub, all of them have their own challenges, but I want to be focused for this talk, so this is mainly an AWS talk. Cool. Without further ado, let us begin with role unchaining. So just a quick intro to AWS IAM roles. Let's say we have a user named Alice. Alice can assume a role. Specifically, Alice assumes the developer's role. With this role, Alice gets all of its permissions and is able to interact with a bucket, a Lambda, a Bedrock model, whatever developer's role can interact with. Now, when Alice assumes the role, she can choose a session name. Alice is a very diligent and very loyal developer, and she chose the name Alice Session because she wanted the traceability. So how does it look like in the logs? We have here a put bucket policy, one of the events made by Alice through the developer's role. And we can see that we have the session name that Alice chose for herself and the role name, which is pretty cool. We have the log, we can connect it to Alice because she chose the Alice session name. Unfortunately, session name is chosen by Alice. It's a user-controlled field. Alice, although she's a very diligent developer, could be using some kind of external library that manages the assume role process for her. This library, for example, choose to put AWS SDK and a timestamp inside the session name. This is a very common pattern in the cloud. Once Alice chooses to use this library, what we see in the logs is AWS SDK and the timestamp and the name of the role. Nothing points us to Alice's direction, which from the SOC perspective isn't that good when we want to figure out what happened and who did what. This is even more tricky because if a user can control this field, then we must think of not just the naive user who's using a library that masks their identity by mistake or unknowingly. A user can be malicious, and the user can choose to point us at the direction of a colleague they don't like, or just someone else in the organization, and mask their identity under, for example, here, Alice chooses the name Bob as the session name. And now every activity made by Alice in this specific session is logged with Bob's name and the developer role. So it's not just that we don't know who did what, we get point to the wrong direction. I've blabbered for a while now, so I just wanted to stop and see if anyone has any question. Okay, cool. So this gets even more complicated and more tricky because of the concept of role chaining, where Alice can not just assume a single role, but inside the first role, she can assume another role and another role. And only after these roles are assumed, she can choose to interact with all of the resources in the cloud. Each of these specific roles can be assumed with a different session name. There's no restriction on that. So everything gets masked and obfuscated through an infinite chain of role assumptions, which again is very difficult when you're trying to figure out who did what and what happened when you investigate an alert. So now, as I said before, I built stuff for SOC teams. So from the SOC perspective, why should we unchain? Why should we, and what's unchaining? Unchaining is essentially being able to look at an event here, the event with a put bucket policy, and know that the original entity, the original actor that did stuff is Alice, to not get confused by the developer's role. So why is it important? Finding the actor, finding the origin of an activity is essentially it's the first step of the investigation. After you do that, you can try and build a timeline. Before you know who did what, you can't really see what else did they do and build your timeline of the attack. After building the timeline, you can build a blast radius. You can see with which resources did the attacker interact with and what was the effect on them. And only after having the blast radius and impact, you can remediate and respond. But all of these steps are dependent on us knowing who did it, who's the actor. So for most of the investigations in AWS, unchaining the role chain is a crucial first step to understanding what happened, to investigate, and to respond if needed. So that's a big deal in AWS and for AWS SOC teams. Okay. Yeah, Don, I see that you have a question.
Yeah, can you go back to the previous slide where you have the visualization, the attack path visualization? So here,
This.
right? If
Mhm.
yeah, so if Alice is essentially an attacker that's assuming the DevOps role, the DevSecOps role, the developers role, um, I feel like in an actual attack, they don't actually know what role maps to what. So in reality, it's kind of like getting the DevOps role to role one, role two, seeing what access that they have. Um, how does that not almost like allocate for more triggers? Is there like timing that attackers wait to take those actions so it doesn't like almost flag, hey, someone's trying to assume a bunch of roles at the same time from something we haven't seen before?
That's a great question, and there are actually like multiple types of attackers that I saw. There are what I call drive-by attackers. They usually start by an access key that's been exfiltrated through a GitHub or a web page, and then they just run amok and try everything and try to assume a bunch of roles and try to discover what's happening, and whatever they try, whatever is successful for them, they try. So they can try to assume a role and then from it to assume another role if the original role wasn't high privilege enough. And these attackers are quite noisy, and you get a bunch of opportunities to detect them. Even with that, having the ability to trace like very easily all of the things that they did under multiple sessions can save you a great deal of time when you build a timeline and when you're trying to like figure out what was the impact. But you're correct. For these kind of attackers, they are usually, if you have a decent detection engine, they'll be discovered quite fast, hopefully, knock on wood. They're like another type of attackers. These attackers are more sophisticated. A lot of the times they are like insider. We've actually seen a specific insider where they did exactly that. They try to obfuscate their identity by assuming a role and then assuming another role and taking their time in the environment. So a role chain is something that we can't really trigger an alert for whenever it happens because it does happen in the wild. Role chain of 5 roles, we can trigger an alert for that. But 2 to 3 roles, it's a bit, it could get very noisy. And these sort of attackers, they can use role chaining to obfuscate their identity, to try to throw people off. So I've seen both type of attackers. And for both of them, unchaining really helps like for starts to realize what happened in the big session, not the session of the specific role. And sometimes it really helps to detect their activity. I hope this answers your question.
Yeah, and the only follow-up I have is so it seems like for attackers like this, not only is there a high level of knowledge that people must have in order to do this, it also sounds like for the sophisticated ones, there's actually an oddly extreme amount of patience in order to know and understand and almost like stay and persist.
I think there's a frustrating gap between attackers and defenders. Doing 3 assume roles is very easy. It's like you can ask ChatGPT how to do it. You get a script in your favorite language, and there you go. Unchaining like a vast amount of logs is very difficult. So I think there are attackers with a lot of patience that like move slowly and discreetly. But this specific technique, it's not that difficult for an attacker to pull off if they have the patience to do it.
Got it. Cool. Yeah, thanks for your insight.
Cool. Yeah, Aaron.
When it comes
Aaron,
to
I see your hand up.
yeah, thank you. When it comes to role and chaining, what is the common thread that allows you to trace it back to Alice after going through the multiple different chains?
So that's when I was
Magic.
a young cadet, they told me that an amazing question is a question that you have a slide for. So we have that slide.
Awesome. Thank
So
you.
so thank you for the amazing question. Cool. So as we said before, finding the actor is like a prerequisite for a lot of the investigation steps. And for specific for AWS, and chaining is key. Now, we had multiple iterations to try and create a trail breadcrumb that leads to Alice or to the attacker. And so what are we trying to do here? We get an event, we check was it made by an IAM role. If it's not made by an IAM role, then we're done. We got the original entity, the original actor that did stuff. If it was made by an IAM role, we should search for the corresponding assume role event and then check if this event, the assume role event, was made by an IAM role. If it's not made by an IAM role, then we're done. We found the actor. If it was made by an IAM role, then we have role chaining and we need to do it again and again and again until we reach the original entity. So this is what we're trying to build here. We're trying to like build the red box. How to search for an assume role event given a suspicious event that you want to investigate. Cool. So the first breadcrumb that I saw when I started working on it like a few years back is the access key, access key ID to be more precise. Whenever you do an assume role, you get temporary access keys. They are composed of a secret, like I think 2 secrets, I don't recall their names, and an ID that like points to the specific temporary access keys that were generated through the assume role. You can spot the temporary access key IDs by them starting with ASIA. Non-temporary access keys start with a Kia. So that's a cool trick. And these access key IDs, these temporary access keys ID that you get when you assume role, will appear under every event that you do under this specific session. So you can take the temporary access key IDs and search for them in the response elements of the assume role log. So you like the attacker did an assume role event, it is logged. Inside the log, there is the temporary access key IDs that appear in the suspicious event log. That's a way to connect. So we saw that and we were like, cool, there's our breadcrumb. This is what we need. And we came up with this scheme and we were very happy about it until we saw a bunch of temporary access keys that we never saw a correlating assume role event for. And that was a bummer. That wasn't fun at all when we saw that. And we started to look into it and see why from where does these temporary access key IDs come from. Because as I said before, role and chaining is a big deal, and we must have it when we build a platform for SOC teams. Okay, so we found a bunch of quirks. One of them is the console quirk. That's how we chose to name it. Essentially, people can access AWS console through federated console session. What it is you do an assume role, you get your temporary access keys, and then AWS has this way to federate this session into a console session. Inside the session, any activity made will be logged with a different set of access key. These almost random temporary access key IDs that appear in the events made through the console have nothing to do with the assume role event that we started with. There is an actual tool that is very favored by attackers called AWS Consular. I saw it multiple times, and attackers can use it in order to create a console session with a session name they're choosing through what we saw before. And everything that goes inside this console session won't be logged with the relevant access keys. And so that's like a bummer. And what we realized is that attackers don't use the AWS consular because they want to obfuscate their identity. It's not what they do. AWS console is actually a very cool and neat way to do reconnaissance in the environment, because AWS built a very nice console with very nice search opportunities and search tools. And a lot of the times, attackers just use this to understand what's happening. It's much easier than to build a script that do discovery. And so attackers love this tool, and because they use it a lot, it sort of messes with our way of unchaining the whole assumption chain. I think that this was a big slide, so I want to pause and see if anyone has any question. Cool. Okay. So this is off the table. We can't use the access keys as breadcrumbs for unchaining. It's not good enough. It's not robust enough. So we need to find better breadcrumbs. And we found one. We found some. We actually found multiple fields to use as breadcrumbs to find the assume roles in the chain. We call them the identity tuple. These are 3 fields. The session name, that's pretty cool. The attacker can choose a session name like whatever they want, and we can't use the session name to understand who did the activity, but it is a very nice breadcrumb into the assume role, because while it's not like if the session name is Bob, it doesn't necessarily mean that Bob did it, but Bob will appear both in the suspicious event and the corresponding assume role. So this is pretty cool. So we have the session name, we have the role name, which obviously appears in both the suspicious event and the assume role. And we have the session creation date, which is again a very cool field. Every activity that's been logged in CloudTrail have this event when it's made by an IAM role, session creation date. This is the time of the assume role event, plus minus a second. But essentially, this is the time of the assume role event. So these 3 pointers are amazing pointers to the previous assume role. We can see them here in the JSON in the event. So we have the session name, that's like the second part of the principal ID, Bob. We have the creation date. This is the time where the assume role happened. And we have the developer's role, the name of the role, or the full ARN of the role. We can use that in order to search the corresponding assume role event. So we're looking for the creation date. We're looking for it in the event time. This is the same creation date as the event time. We're looking for, in the request, the specific role that was made, that the attacker assumed. And we're looking for the session name that the attacker chose for themselves. So that's a very cool way to unchain the role assumption chain using the specific actor controlled field that was used to sort of throw us off. So that's pretty cool. And we have a new method for unchaining. Start with an event. If it was made by an IAM role, then you search for an assume role with the same event time as the session creation date, the same role and the same session name, and you do it over and over again until you find the original entity. Having found it, you win. You can start and do the other parts of the investigation. Okay, so this methodology works like a charm. It's really nice. It actually helps us to unchain across multiple accounts. If we have like the entire organization and we see an entity in one account assumes roles into another account and then to another account, we can actually use these identifiers to unchain across multiple accounts in a single organization, which is pretty amazing. So this, up until now, I haven't seen a case where this methodology failed us, which is pretty cool. Any question about that before I move to the, like, when do we apply this methodology?
Tell me if I'm going down a rat hole, but how much does this, I don't want to say break, but how much does an external IDP complicate this? So let's say you have an inside actor and the company is using Okta, and somehow the inside actor is using Okta to get to that first assume role, so you don't actually know who the real actor is. He came in through an IDP, right? Does that complicate it a lot?
So an IDP actually simplifies stuff, because a lot of the quirks with the access key IDs don't apply with the SSO user, with the new identity scheme for AWS. A lot of the quirks come from IAM users and the way they interact with roles and the console and CloudFormation. There's another quirk. And because IAM users and IAM permanent keys are still very frequent in environments, we see them a lot. And because attackers love these, that's why we put so much effort into role unchaining. But for SSO users, role unchaining is still a thing, but it's actually much easier. And you can use the first set of breadcrumbs, the access key breadcrumbs, to sort of understand what happened. It's pretty cool.
Okay, so what you're really saying is the fact that those access keys, they don't identify a person, just actually they could be from GitHub, they could be found anywhere, right? The identity stops right there.
Yeah, so it's that, and also there are a certain set of restriction that AWS has for assume roles when you're under assume role with SAML, like the SSO user roles, SSO users. So because of these restrictions, the room to sort of wiggle that attackers have is stricter. It's lower, so it becomes a lesser deal. But unfortunately, IAM users and IAM access keys are very common. So we need to deal with it.
So get rid of users. Okay. Let's move on.
Itay, there's a question in the chat. I don't know, Hussein, if you're available to go on mic. If not, I can share the question.
I don't see it because I'm sharing the screen. So please feel free to share it.
Oh, and so Hussein, that might be one to say, but basically he's asking if logs are monitored 24/7. It really depends on how you operationalize your cloud, to be honest. There's tools that will monitor it. There's always log collection. It's just a question of whether or not people look at their logs, analyze their logs, or connect their logs to a SIEM or whatever. But yeah, your question is really goes more to how did you operationalize the cloud, I think.
Well, Sean, I think another aspect of the question is, at what point are you alerted and start checking an event? So I guess, like, if you have a team that is looking at it 24/7, like different shifts, I guess alerts can be consolidated by this event happened under these conditions, we'll generate an alert for it. And then just because an alert is generated, does that mean it's investigated right then and there? Perhaps there's different levels of severity or priority that people put in. I think that might be more towards what it was leaning.
Yeah, again, I'd say it's all about operationalizing, right? You set up policy for that and then react to it accordingly. But I'll let you talk to that.
Yeah, so I really agree. I think different SOC teams have well, first of all, different resources. Like there are very small SOC teams and there are huge SOC teams, and this really influence how frequent they're able to look at different alerts and which type of alerts are being monitored. Is it only the critical and high severity or everything? I think what I'm talking about when I'm talking about role unchaining is when you investigate an alert, you need to be able to very quickly understand who did it. And what we try to do here is to create a methodology for SOC teams whenever they have time to investigate a specific alert, to just have it, like have all of the sessions that are connected to a specific alert when they start from a specific event. So the starting point is an alert, a specific event or a set of events that triggered an alert. And then you need to investigate quickly. For that, apply role unchaining. And I hope this answers it. Cool. I want to say one more thing before I move on to like a question to another stage of the presentation that really discusses when do we unchain. There is a tool for AWS or a mechanism called source identity that AWS allows you to apply to make sure that it doesn't really matter how many role chains you have, the original identity will always appear in the log. Unfortunately, I have never seen an organization that deploys this mechanism in all of their accounts across all of the organization. And I think it's a bit difficult to deploy, like from the experience I had with it, but I don't want to bad talk about it because I never needed to deploy it. But this is something I think is worth mentioning. It's worth looking into, but I've never seen it really like fully deployed. So again, this is why we put so much effort into role unchaining. Okay, so there is a question. When do we unchain? When do we apply this mechanism? We can apply role unchaining on demand, like just like we talked about a minute ago. When there is an alert, when there is an event, we can unchain, like there is a suspicious event, unchain, get the original actor and move from there. Another possibility is to unchain everything all the time. Like every activity made by an IAM role will be unchained during ingestion time, during the time where you collect your logs to your favorite SIEM, Splunk, data lake, whatever you put your logs in. So these are the two options. And we need to talk about the pros and cons. So unchaining on demand, I think the biggest pro is that it is so much easier to implement. You don't need like engineers that are able to move around with a huge amount of data. You have this mechanism we talked about with 3 specific breadcrumbs. You can build an SQL query, and there you have it. And you get the first benefit of the investigation. You have a suspicious activity, boom, you can go to the actor that did it. But there are cons to it. And there are specific detections. Sorry. There are specific detections that can't be implemented without role unchaining from my experience. Maybe someone else was able to do it. We weren't. And we needed role unchaining to pull them off. And I think there are some very cool investigation features that you can build on top role unchaining when you have it like across all of the events in the organization. So I want to talk about that and shed some light on it. First of all, the breakdowns. Something extremely valuable when you investigate an alert is to understand if this is common behavior for the actor, for the entity. If this is a common behavior, then you should, again, look into it. but it lowers the level of suspicious. If this is a very non-common behavior, especially for an actor that is there, that exists for a while, this raises the suspicious level a lot. Here, we can see a breakdown for an access key that was a part of a red team that we simulated in our demo environment. And we can see that this access key is here for a long time. And then in a single day, there was like this burst of enumeration and recon activity and exfiltration activity. So this is very suspicious. The ability to build a thorough and complete breakdown of what a user did, what an IAM user did, is dependent on being able to unchain. Because if for an IAM user, all they need to do is to assume role or assume role twice, and then they are off your breakdowns, and you don't see their activities in investigation breakdown, then this is not a good enough tool. So the ability to create these investigation breakdowns really depends in AWS on role unchaining. And I think on role unchaining in ingestion time, like that everything will be unchained. So I think that's a very cool feature that is a bit overlooked whenever I saw discussions about role unchaining and role chaining. Okay, I think that was a big slide as well, so I'll stop for questions. Cool. The other thing is the detection engine. Let's say that we want to build a baseline for the activities, or like for common activities in the environment, to single out very unusual suspicious activities. For example, a cool example with data events, with S3 data events, is mass access to multiple buckets. This is a very common pattern for exfiltration. Now, if we only look at roles, the role really masks the activity. For example, we have a developer's role. It seems like this role interacts with multiple buckets. With some buckets, it interacts more, with some less, but it seems like the role interacts with a lot of different buckets pretty usually. But if we have role unchaining and we get to see the actual users behind this activity, we can see that there are users that are very frequent and they create most of the activity by the specific role. And there are users that are not that frequent or are only frequent with specific buckets. There are users that almost never interact with a single bucket. So if this specific user, even if it assumes the developer's role, will try and touch a bunch of buckets and like a bunch of objects inside every bucket, this is suspicious, and you should consider triggering an alert for that. And again, this wouldn't be possible without role unchaining to create such a detection. So this is, again, another benefit of doing it in ingestion time. So yeah, I think like this maybe answer the question that was asked before for like, is your cloud events are monitored 24 hours? There are multiple ways to monitor them and multiple processes that you can apply to enrich them and make them more clear and reveal more stuff. And you can do it like in mass scale, or you can do it for a single event. And these are the pros and cons and like the benefits of doing it in a very big scale. Any questions about that? This is the last slide for role unchaining. From here, we're moving to parcels. So we can maybe stop and just talk about it for a while if you want to.
No, this is a great topic, Itay. I think a lot of the questions in the chat are revolving or around cost benefit, right? Like, because a lot of this involves a ton of analysis, either in real time, which costs money, or a ton of log collection that you look at later, which costs a lot of money. And, how do you figure out, for a lot of folks, they've got small operations, right? How do you figure out what to spend on doing this, how much effort to put in place? yeah, I think people struggle with that question, but yeah, this is awesome.
Cool. I think when you have a small operation, you can be more strict with the detections that you have, and this really allows you to do unchaining only on demand. As your operation gets bigger and bigger, your ability to be strict is lesser because there are like a bunch of noise in the cloud. So when you have a really big operation, I think being able to unchain like vastly in scale, maybe even for your accounts, for like your production accounts, is quite crucial. It is a lot of heavy lifting. There is like a whole part of this talk that I'm not doing because I didn't implement it, which is how to engineer ingestion time role and chaining. I saw my friends do it twice, once in Gem, once in Wiz, and it is very difficult. So like I understand that doing it ingestion time is very hard. I think if you're having like a huge operation in the cloud, it could be very beneficial. I saw that someone asked about GuardDuty, and something like which was quite surprising for me about GuardDuty, you don't get unchained entities in GuardDuty. You get the roles and you need to unchain on your own. And you actually, to do that, you need to find the CloudTrail event for which the GuardDuty alert was triggered, because the breadcrumbs for unchaining doesn't appear on the GuardDuty alert. So this is like a nice, not that known thing about GuardDuty alerts.
That's super interesting, actually.
Yeah, I spend a lot of time looking into GuardDuty because we want to be able to help SOC teams investigate GuardDuty as well, not just our alerts.
I think GuardDuty is one of those things that's actually really useful in some ways for the smaller environments, right? As you grow, the GuardDuty alerts end up being almost useless unless you have a lot of other context and correlation added to them, right? But in the small environments, it's something that actually makes sense. It gets too expensive in the big ones and becomes useless.
Allow me to stay out of trouble and not respond here.
Oh yeah,
cool.
We're being recorded, I should say.
Yeah, yeah.
He's pleading the fifth, and he's not an American. Just want to call that out.
I've worked with Americans for a while now, so cool. I think we have time to talk about parsing, but I'm not sure. Sean, what do you think?
Oh yeah, we've got time. We got 15 minutes left. It depends. If people have questions they want to start asking about, threat detection in general, we can do that. We can, we certainly have more content. We've got about 15 minutes left.
Hey, Sean, I got to run, but I just want to say, Itay, great presentation. Thank you so much, man. Thanks for joining. I really enjoyed it. So thank you so much, and I'll see everyone soon.
Thank you,
Chris.
Yeah, same here. I have to run, but this was fantastic. Thanks, Sean, for putting this together, and Itay for your presentation.
Thank you so much.
Awesome. I can actually stop the recording and open it up to a little more free discussion if you like. Or did you have more slides, Itay?
I have the parsing slides. I think it depends on your but it depends on the form. I can start with the parsing slides, and if someone has a question about role unchaining or detection engine or how to build detections, I really love to talk about it. Cool. So let's go back. Okay. So before we start talking about parsers, let's see that we're aligned on what is a parser. A parser is a black box that gets an event and is able to extract resources, cloud resources. What is a resource? A resource is the identifier of a resource and the type. S3 bucket, a Lambda function, a Bedrock model. That's the sort of types. For example, we can look at a put user policy event. The parser, I will expect it to extract the user and the policy, the policy. Okay, creating a timeline with parser is beautiful. Let's look like at a specific attack. There is a console login by an attacker named Eve. Then Eve starts a session with an EC2 instance, a privileged one. Using the EC2 instance privilege one, a privileged role, it creates a user called test user. It applies an administrator access policy to the user. It then changes the access of an S3 bucket, the bucket policy, and then extract a bunch of data from the sensitive bucket. So what's the parser here? The ability to go to the EC2 instance machine, privileged machine, the ability to extract the test user, the policy that was attached to it, the bucket that was interacted with. All of these are the result of good parsing. With a good parser, you can build an amazing investigation graph, which really helps you see what happened. And again, this is very helpful. From a single glance, you understand what happened in the attack. Someone connected to a strong machine, created a user and gave it admin access, mostly as a backdoor, and extracted a bunch of data from sensitive bucket. Without the parsers, things look like less informative, like a bunch less. You see that Eve started a session, but you don't know to which machine. Then you see that a machine was created a user, put a bucket, gave it permissions, you don't know which, interacted with some bucket, you don't know. Actually, without the parsers, you wouldn't have the ability to connect the first two events, the start session by Eve, with the later set of events by the machine, because the way that you connected it is Eve started the session to a machine, and then the machine started doing stuff. So without the parsers, you wouldn't even have the full context of what happened, and you wouldn't be able to reach out to Eve, which is the actual actor, not the machine. So parsers are important. We love parsers. Is it an issue? Well, for GCP and Azure, it's not that much of a big deal. The events are quite ordered, and you have, like, there are some outliers, but for most events, all of the resources are set in the exact same place in the JSON. For AWS, however, things aren't that great. For example, I wanted to extract the subnet ID of two different events under the event source EC2. In one event, the modify subnet attribute, we have request parameter, subnet ID, there it is. So a very simple parser. For another event, request spot fleet, we have request parameters, request spot fleet request config, launch specifications, subnet ID, subnet with a capital S, which is different than this subnet. So that's very common across AWS events. And that's a problem, because we want to be able to extract these meaningful resources from different events. Okay, so how do we approach this? The first way to do it is through regex. There are a lot of IDs that are very unique and regexable, for example, for security groups, subnets, VPCs, and you can just scan an event with regexes and find them and extract them. Very easy. Another cool way is ARM. A lot of the times, CloudTrail events contains the full ARM of an identity, and you can regex the ARM. And even though admin group is just text, it's just words, you can regex the entire ARM, and then you know that this is admin group. But this isn't enough, because for a lot of important resources, their ID is a name, like any string can be there, and you need to be able to extract them. So we tried a lot of different approaches to do that. I want to be time conscious and just like skip to what worked for us and how we build it. What we did, and it was really nice, so I thought it might be interesting for you, is cross-referencing logs and inventory. So like a lot of cybersecurity companies back in Gem and in Wiz, we have an inventory, like a bunch of resources that appear in your cloud environment that we extract through API calls. These resources might have indicative name, distinct names like temp function test John. This is a very distinct name. No other resource has it in the environment. And there are some non-distinct names like prod1. For distinct names, they are tagged because they're inside an inventory. We know that temp function test John is a Lambda function and that this string is an RDS instance. We can then search for these specific strings inside CloudTrail events, find events that contain them, and then sort of see where these events lie inside the event, where these strings lie inside the event, and sort of build the parcel from there. If two distinct names of RDS instances are under request parameters DB instance identifier, then I can deduce that this is a path that leads us to an identifier of an RDS instance. And this is pretty cool. There are ways to boost this technique when you understand that a lot of resource types, they appear in very different places in the events, like we see here. Like these are very different places, but other than the cap, subnet ID and subnet ID with capital S, the last stage of the path is very similar. So if you're able to locate the very close set of last stages in paths of identities, then you can create parcels for these specific last steps. I call them petioles, which is like the tiny part of the plant that connects the leaf to the plant, because I'm, as I said in the beginning, a geek. Yeah, so that's a cool way that we created the parcels for AWS CloudTrail, and we're able to create these parcels in scale. And I think this is like could be very beneficial as a methodology for people who are trying to build better, more informative timelines and to do better pivots when they investigate an alert. So that's why I wanted to talk to you guys about it. I think we have 5 more minutes, so I'll stop blabber and let you guys ask stuff.
Kind of a general theory question, and more like bringing outside of AWS and more cloud in general. Like, which cloud service provider is harder to kind of do this kind of role unchaining and like track an actor through when they're pivoting through roles? Like, are some cloud service providers more complicated than others in doing that kind of like IR investigation?
Yeah, so GCP are the easiest one because even inside multiple impersonations, there's like a struct inside the log with all of the stages of the impersonation. And so
okay,
GCP did a really good job with that. AWS, since we've built this methodology, for me it's quite easy now,
right.
but it took us some time to get there. For Azure, it's a bit complicated because for Entra ID, you really don't have these concepts of roles.
Right.
For managed identities, it's again, you don't have the concepts of a managed identity inside a managed identity, but there are some complexities when you try to pinpoint which specific resource has used this managed identity, because managed identities can be shared across multiple resources. So that's like a specific part of investigation in Azure, which is quite difficult. So you have to correlate with IPs, which is like a worse breadcrumb than the breadcrumbs for AWS.
Right. Okay, that makes complete sense. Thank you.
100 percent agree, Itay. Google definitely the easiest one. AWS hard but makes sense. Azure, what the hell is an enterprise app?
Yeah, yeah. And resource logs also have their own quirks. Like a lot of SOC teams don't even look at resource logs because it's quite complicated to set them up. But identities in resource logs have their own problems. So yeah, Azure, it's a bit more difficult to do that. But for me, it's cool because it's job security. So I like that.
Our joke is that even Microsoft doesn't really get AD.
Any other question?
Right, I'm gonna stop the